So now we discuss about hypertonic lesson 35. Previously in previous class we studied about hypertonic solutions. Hypertonic solutions. So hypertonic solutions. So that means solution divided on the basis of what? Osmotic pressure. There was three categories of the solution. That is hypertonic, hypotonic, and isotonic. So hypertonic solutions, we have discussed that it have higher osmotic pressure from the another solution from which it is separated it is separated by the semi-permeable membranes. That means if a cell put in the hypertonic solutions, then the cell size will be reduced. Here the cell size reduced due to the exosmosis. What is exosmosis? Exosmosis is the outer flow of water from inside of cell to the outside of the cell. Outward flow of water from the inside of cell to the outside of the cell. Suppose this is a container, and in this container what happens? Suppose I have take a cell. This is the cell, and suppose the solution is hypertonic solutions. And cell is itself is the cell, and it is the what? Cell membrane. Suppose this is the cell membrane. So inside the cell there is also a solution. So here it is hypertonic solution. Here cell inside the madhya the solutions achi. So what happens? Hypertonic solution have what? More osmotic pressures, having lower amount of water. Water amount is very less here. So what happens? Cell membrane, through the cell membrane, water will passes from inside of cell to outside of cell. That means water cell bahar ko bhai ke hypertonic solution algo polebe. যেতବେଳେ সেল ভিতরু ওয়াটার বাহারକୁ পଳେଇ ଆସିବେ ସେତେବେଳେ ଆମେ ତାକୁ କହୁଛେ ପ୍ରୋସେସ୍ ଏକ୍ସୋସ୍ମୋସିସ୍। ଏକ୍ସୋ ମିନ୍ସ ବାହାରିବା ବାହାରକୁ, ଆଉ ଅସ୍ମୋସିସ୍ ମାନେ ଅସ୍ମୋସିସ୍। ତ ଅସ୍ମୋସିସ୍ ପଦ୍ଧତିରେ ବାହାରକୁ ସେଲ୍, ବଡି ଭିତରୁ ବାହାରକୁ ସେଲ୍, ବଡି ଭିତରୁ ବାହାରକୁ ୱାଟର ଫ୍ଲୋ କରିବାକୁ କ'ଣ କୁହାଯାଉଛି? ଏକ୍ସୋସ୍ମୋସିସ୍। ତ ୱାଟର from the inside of the cell moves out to outside through the semi-permeable membrane. This is called exosmosis. These things happen at that time when we put the cell into the hypertonic solutions. So after what happens? After putting of the cell into the hypertonic solution, exosmosis will happen and cell size will be reduced. That means if this is the original size of the cell, then cell size will reduce to here. This is the reducing size of cell. This is all about what? Hypertonic solutions. Hypertonic solution. Now we see hypertonic solutions. Hypertonic solutions have a have low osmotic pressure from the another solution from which it is separated from which it is separated by the SPM. SPM means semi-permeable membrane. That means hypotonic solution is what? Hypotonic solution have low osmotic pressure. So hypotonic solution have low osmotic pressure achi from the another solution. How good solution to? जो solution to is separate है का द्वारा semi-permeable membrane द्वारा. Suppose this is SPM, semi-permeable membranes, and this is the solution. Suppose hypotonic solution, and this is another solution. So hypotonic solutions have osmotic pressure lower than this pressure, these solutions. So what happens? That means this solution have higher osmotic pressure. So if I put a cell into the what? Hypotonic solutions. Suppose this is hypotonic solution, then the water from the hypotonic solution will be entered into the what? Inside of the cells, and this process is called the endosmosis. This process is called what? Endosmosis. That means hypotonic solution have a low osmotic pressure from the another solution from which it is separated by semi-permeable membrane. If I put a cell into a hypotonic solution, endosmosis will be happens because water from the hypotonic solution will enter into the inside of the cells. When water entered into the inside of the cells from the outside, it is called endosmosis. Okay, so if I put a cell into hypotonic solution, then cell size will be more, it will swells. Okay, this is all about your hypotonic solutions. Isotonic solution. In isotonic solution, have same osmotic pressure from the another solution from which isotonic solution have the same osmotic pressure as the another solution from which it is separated. It is separated by semi-permeable membrane. So isotonic solution have same osmotic pressure as another solutions from which it is separated by the semi-permeable membrane. Suppose this is the container, and this container, suppose here this is suppose isotonic solution, and suppose this is another solution, and its osmotic pressure is equal to this osmotic pressure. Osmotic pressure is same for this solution, that means both the solutions have same osmotic pressure. Then water will never move from this side to this side, from this side to this side. Water will not move from this side to this side, from this side to this side. So nothing will happen if a cell put into the isotonic solution. The cell never swell or not what? Sink. Okay, this is all about the isotonic solutions. Osmotic pressure now, we discuss about our colligative properties, that is osmotic pressure a colligative property, osmotic a colligative property. So here you can write osmotic pressure is the hydrostatic pressure. Osmotic pressure is the hydrostatic pressure. Hydrostatic pressure. Osmotic pressure is the hydrostatic pressure occur due to the water column at the equilibrium. So osmotic pressure, another definition is that it is a hydrostatic pressure that happens during the equilibrium. That means when water moves from the solvent side to solution side after maintenance of the equilibrium, a water column at the solution side will be arise which exert the pressure. So experimentally we can write the osmotic pressure is directly proportional to the concentration of the solutions. So it is experimentally proved that what? The osmotic pressure is directly proportional to concentration of the solution. That means osmotic pressure pi proportional to C, and this is equation 1. This is experimentally proved, that is osmotic pressure denoted by pi is directly proportional to C. Similarly, osmotic pressure also proportional to temperature. That means, if the temperature will rises, evaporation will also rises, increases, so that what happens? The concentration of the solution will increase, water amount will be decreases, and its osmotic pressure will be rises. So this is equation number 2. From the equation 1 and equation 2, we have pi proportional to Ct. Pi proportional to Ct. So pi proportional to concentration, pi proportional to temperature. That means pi proportional to CT. That implies pi equal to CST. Here S equal to proportionality constant equal to what? Which is called gas constant. So S is the proportionality constant here, that value is similar to the gas constant R. So equation, this is equation 3rd and this is equation IV. Thus, equation IV can be written as pi equal to CRT. Here C equal to concentration of the solutions. Here pi equal to N by V into RT. Here C equal to जेहेतु C equal to N by V, because concentration is what? Number of moles of solute present in given volume of the solvent. So here we got pi equal to N by V RT. That implies pi equal to N into 1 by V into R into T. Here N is the number of moles of the solute. N is equal to number of moles of the solute. So number of moles N should be W solute by M solute. So W solute is what? Mass of solute or amount of solute and M solute equal to molecular mass of solute. So by putting the value of N equal to W solute by M solute in suppose this is equation B. In equation B we got we have so we got that word pi equal to N into 1 by V into R into T. That implies pi equal to N value कितने पाइले W solute by M solute into 1 by V into R into T. This is equal to pi equal to W solute into R into T by M solute into V. That implies pi into M solute into V equal to W solute into R into T. That implies M solute equal to W solute into R into T divided by pi into V. So here M solute is the molecular mass of the solute. Here molecular mass of solute. So by the help of osmotic pressure, so we got here what? Pi equal to osmotic pressure equal to N into 1 by V into R into T. This is ideal gas constant, this is the temperature, N is the number of moles of solute, V is the volume of the water. So in case of 1, in the place of 1 we put W into solute by M solute into 1 by V into R into T. So pi will be how much? Pi will be W solute into R into T by M solute into V, and M solute will be how much then? M solute equal to W solute into R into T by pi V. So by the help of osmotic pressure we can calculate the molecular mass of the solute, and also we know that what? Pi proportional to concentration. Concentration means number of moles of the amount, okay, some number of moles of the solute. So as osmotic pressure pi depend upon the number of moles of solute but not depend upon the nature of the solute, hence it is a colligative property.